It's been a while since my last video, but we've got footings. That's right, the office is underway, and I'm working on that with my contractor. What's the next step? Well, you see the rebar is sticking out of the concrete footings. There's going to be putting in the panels. Yeah, what panels? Yeah, so we're using structural concrete insulated panels for this office. And what are structural concrete insulated panels? Well, I've got a little tour of the factory to show you how and what. Is that the right way of saying it? Check. Okay. We've got audio. And we've got video. Tell the audience your name.
Okay. My name is Kim Blackburn. I'm the president of Innovative Structural Solutions, soon to be rebranded to the Total Integrated Panel System.
Well, hi Kim. How are you doing?
How are you?
It's been a little while since the last time we got to meet in person. So I love what I'm seeing here. Looks really busy. You guys have been really busy with your workload?
Yeah, our workload since the pandemic started and up until now has just been, you know, it's I don't even know what to say. It's a lot. We you know, as you well know, we started with our plant here that we moved from back east in 2016. It took us a few years to kind of restart our company and get our product out into the market. And from there, you know, we've been busier and busier all the time with residential, multifamily, apartments and things like that. And then add on the top of that, the application that we found for our product in large industrial buildings, you know, Amazon buildings, you know, extreme.
This is
FedEx,
the tilt-up warehouses,
this is
right?
the tilt-up warehouses that we've been working with over the last couple of years, and that particular market has grown exponentially. One of the reasons is because of the new energy code for buildings like that. You know, in the past, a tilt-up concrete building was just that, tilt-up concrete. Now the energy code applies, and that building is now required to meet the energy code, just like
I think specifically you're talking about how the energy code has a requirement of any heating over 17,000 BTUs requires full prescriptive insulation, which is building. Like here in Utah is R19 for walls and R38 for the roof, which you just can't hit with tilt-up without having integrated foam.
Yeah, either integrated. We've seen some companies come back in and want to use an adhesive and attach foam on the inside of a wall. But the problem with that, you know, as you probably can well guess, in an industrial setting where you've got forklifts and things moving around, equipment setting things all over the building, it's not very long before the foam's damaged and it's falling off on the floor, and it's not very, you know, it's not a good sight. So what we have done is we've taken our panel and we have integrated it, and our panel is extremely strong. So it's not only just an insulation; it's part of the structural wall. So right now, on a typical tilt-up concrete building, that would be a wall that would be anywhere from 10 to 12 inches thick. We're able to reduce the actual concrete in that wall by 50%. We're also able to reduce the tied-in-place rebar that they would normally have in that wall by anywhere from 80 to 90%. So we're able to give the general contractor a structurally sound wall, and it's engineered. We have more and more engineers every day that are getting involved in the design of our system, as far as tall walls and things like that. And we've had testing on our system to the point where our system has been labeled as fully composite. That means that we have two withes of concrete. They act as if they were one. And so you don't have to make any exceptions, like saying, well, you know, we can build with the tip system, but we have to make this allowance or that allowance. There are no allowances that are required. So by doing that, when you put our system in that wall, you reduce the concrete, you reduce the rebar, and yet we're still structurally strong because of our welded wire reinforcement cage that is inside that wall system.
So I wanted to go back real quick to the rebar issue. That's a huge savings. I mean, like when you're able to save that much rebar, especially with people worrying about carbon footprints and things like that, being able to reduce that much steel out of your building, that's a tremendous reduction in your carbon footprint. So this would be great for architects and engineers who are trying to provide a solution for their clients who are looking to hit net zero and green globes and LEED requirements.
LEED certification, and not only is it with the steel, but and I'm not sure, whether you're aware, but one of the largest industries, the concrete industry, has the biggest impact on that green. The CO2 that comes off of concrete, and by reducing that by 50%, we're cutting that by 50%. So it's the steel, it's the carbon footprint reduction by reducing the concrete. So there's a lot of side benefits that we look at it too. As a manufacturer, if you're looking to do a LEED certified building, one of the sections talks about your products and who manufactures them and what waste do they have. And we're 100% U.S. made. We put nothing in the landfill. So any steel we have that's extra, we recycle it. The foam that we have, we've bought a foam muncher and we grind that up and we repurpose it to other industries for building picture frames and things like that. So we're here. We have no waste that goes to the landfill whatsoever.
That's astounding. It really is. Because that's almost unheard of in any industry to be able to hit that level of recycling. So let's talk about your business name. So we've got Instruct, the logo there, Innovative Structural Solutions. But in talking with Marcus, he was telling me about tips.
Right.
So tell me a little bit more about the branding change.
Well, when we moved out here, we searched for a name and we thought, well, this is a fairly new, innovative product. So we started, trying to put our name together with innovative in it. And we finally landed on Innovative Structural Solutions. And that's kind of a mouthful. Especially when you try to put that on a website or in an email address. So we cut that down to Instruct, which was taking INN out of innovative and STRUCT out of structural, and you get Instruct. And we've had that now for 6 years. We recently have been working with a marketing company that's nationwide, and we sent our information to them, and they sent it out to so many thousand people, and they said, so what do you think of when you see the word Instruct? Well, it doesn't come up construction. It comes up education or some type of online instruction programs or things like that. And so we felt like maybe it was time for us to finally land on a brand that we could carry on for years and years forward. So we came back to the fact that our system, by testing, in the testing we've had done with it, They called it a total integrated system. And so we played around with words and we came up with the total integrated panel system. And if you take the first letters, that's TIPS.
Mm-hmm.
And that's very easy. We're changing our website to tipspanel.com. Our website will be, tips.
Which that's going to make it really easy to make it the aspirin of the industry, right?
There you go.
Like what I've been telling people when I try to explain to them what this panel system is, I call it Structural Concrete Insulated Panels, or SCIPs.
And that's
which I think is more of the industry neutral term, because there are other manufacturers that do this kind of panel system, especially in other countries.
Yes.
But in the United States, I'm not aware of very many that are doing this. It's I think there's like two.
Us and one other is all there is.
And they're based in California, right?
No, the other one is based back east in I think Illinois, and most of their work is in the mining industry.
Oh, okay.
And they make mine seals and shaft supports and things like that. And the other company, our company, was in Charleston, South Carolina, and we moved it here. Well, one of the actual things that I liked about Instruct is I always like to feel like that, when I go back to my early working days, I was in the education field and so teaching, and so it's always kind of been a part of what I do. And I always feel like that with our system, because it's not something that's been around for generations and generations, that what we're doing is we're instructing architects, engineers, builders, even end users on the benefits of TIPS. And so most people, I've had so many architects and engineers come to our manufacturing plant because they're like, how do you push all those pins through there and weld them on? And I'm like, I don't. That's our equipment. That's our manufacturing line. And they're like, a manufacturing company builds this? And I'm like, yes, we do. And we walk through, and when we get all through, they're like, I had no clue, no idea that this could be handled in a manufacturing setting. And then when we really look at the actual design of the panel and the truss wires and the strength that's gained and how that shares load and distributes weight, it really brings it home. So I don't feel like I sell people, I just give them the facts. And I guess I kind of teach them the things that are important, and then because trust me, if I had to be a salesman, I'd starve to death, because I'm not a salesman.
You and me both. I hate sales, but I've found that's a similar thing when I'm talking with new clients. I just provide them my honest professional opinion and give them the facts and the science that I've learned over years. Mm-hmm. And that does more to sell people on using my services than anything else.
Yeah. And
and for me, unfortunately, it's more about selling me than it is just selling a great product. Which that's, with that segue, let's just go ahead and let's take a look at the plant. Let's see how to make these.
We can walk in, you bet, not a problem. So.
All right. Well, hopefully this is where the lapel mics really help.
Yeah, it gets a little noisy in here.
Yeah, it definitely gets a bit noisy in here.
So, presently we have about 25,000 square feet of manufacturing space here in our plant. We're just beginning. I shouldn't say just beginning. We're actually getting ready to begin the construction process on 35,000 more feet on the back. And we plan to add one more full line of our panel manufacturing. We basically have two major lines of manufacturing. One is our mesh manufacturing process, and it's up and running today, and they're producing mesh, and we can walk over there. And then the other line is the line that actually does the welding of the panel.
Okay.
And then we have some ancillary things. We have a shear here and a bender that cuts this mesh that's right here next to us. This particular piece of mesh has a screed built into it, so that, you know, as you put this together, that gives you a way to screed the shotcrete or the gunite very, very flat, so you get nice flat walls.
Okay.
One of the other things we were talking about, our recycling process, right over here is our, you know, we've only had a short time, but this is a foam muncher. So as we don't just build like 8-footers or 10-footers, we build your project. So when we send it out, there's not a lot of cutting on site. You basically have the sizes that you need for the walls, for the house, for the commercial building, whatever it is. So we buy our foam in the sizes that comes from the foam manufacturer, and at times we have to cut that. We have a foam cutting table. We'll have some leftover foam, we stack it up, and then we munch it, and we turn it into these blocks that you can see coming out of that piece of equipment over there. That goes to another company here locally in Utah, and they make picture frames out of it. Okay. So, you know, I feel like it's our responsibility not to add to our pollution problem in this world. We need to take responsibility for ourselves, and so that's what we're doing. We're recycling any of our steel that's left over. We're recycling any of the foam that's left over. So
okay,
that's how that all happens.
So let's talk about the mesh. So
sure.
What, you know, because most of the viewers are architects, what kind of mesh are we using?
This is called WWR, welded wire reinforcement. This is 11 gauge galvanized steel wire. The KSI on this is somewhere between 85 and 90,000 PSI.
Okay.
And we have very tight tolerances on the steel that we buy. It's all recycled material. And so, you know, we're buying recycled material, and then we're not adding to any of the pollution.
And
this is commercial grade galvanization. It's a cold dip.
And the wire actually comes galvanized to the plant?
Yes.
Okay.
Yeah,
and this is on a 2-inch grid.
2-inch grid.
Or roughly 5.5 centimeters, I'm guessing.
Yeah, somewhere in that, on a millimeter basis, but it's 2x2 mesh, as you can see there. Now, the way that we manufacture that mesh is we buy our steel on these larger carriers down here.
So that's down here at the
no, just right here.
Just right here?
Yeah.
Okay.
We buy our steel on these carriers like this. When it arrives here at the plant, then we re-spool it on this piece of equipment here and here. And what we do is we take it from those large carriers, and if you come over this way, you can see these are all empty carriers here. They're waiting to have the wire spooled onto them. Once we have it on there, then it goes over here onto the actual mesh welder. It's called a GNZ machine. So I have.
Okay, so
I have 50.
So this right here. Explain what this machine's doing.
Let's go from here to there. So
okay.
This is our line wires. We have 50 line wires on the mesh that we're going to make. This right here is a cross wire. Now, so we don't have to re-spool it. It just stays on the big carrier. And that wire, as you can see, this wire is all being fed forward.
Okay, so all these wires are feeding in and creating that 2-inch horizontals.
Now this is creating the line wire. This one right here is the cross wire. So the line wires are going this way, the cross wire is shot across them. And then the welder comes down and welds all 50 at once.
Okay.
So right here we're taking that wire off, we take it up through, and we're trying to take the coil out of it because it comes all coiled up on those big carriers. So let's walk down here right here, this cross wire, it's actually spinning backwards from the way it was put on. That helps take some of the coil out of that wire. That wire is fed up through here. We get right here, you can now see those line wires coming forward, and the cross wire is shot across, and then once that is shot across and in place, then that whole weld head comes down welds, like 50 welds at a time, all at once. Once that happens, now we have the mesh welded together. It comes down here, and it goes through this slitter. On this side we have one piece of mesh that's 8 feet wide, and I need two 4-foot pieces for the panel system. So this right here cuts the center out and it trims the edges right here.
Okay. And then all those little pieces then go to the recycling plant.
All those little pieces drop into an electromagnetic chipper. So walk right over here. If you look at this, you can see all those pieces are being carried over here, dropped in this bucket. We put it right in here. This is our recycling material right there. Okay?
Fantastic.
Again, this is more steel that's just waiting for manufacturing. So once we get the mesh to this point, then you can get a kind of a better view of it. You can see that mesh is coming forward, and then the green belts that you can see right here on this this part of it is now putting this mesh under tension after it's been put together. Right here, the cross wire is on the top. When we get over to the other machine, I need it on the bottom. So we take it down, we take it out that way, and we bring it up and we roll it up right here. And we put 450 linear feet of mesh on each roll. Okay? Once it reaches that, if you look at this roll right here, right now it's set up for 452 feet because there's 2 feet that connects it to that roll that we actually have to waste on every one, and it goes in the recycling bin. Right now we're at 222 linear feet. So it'll continue to roll that up. When it hits 452, there'll be an alarm that will go off notifying the operator that we hit the length on this roll, and it stops so he can come over and take this carrier, and it slides over, it clamps down on the mesh. There's a big shear up in the top of that. It just cuts that mesh, and then he actually ties it off. Once he's tied it off, this carrier and that pusher over on that side over there slides it right over here. At this point, we inspect it, we label it. Even though we're using everything that we make, we are an ASTM shop, so that means we're subject to all sorts of inspections and standards. And so every roll we make has a tag on it, so that if one day we decided to sell some for whatever purpose, it has all of the KSI information on it, the date it was manufactured, all of the information that would be required.
Okay.
So
excellent.
We get it over here. At this point, the machine releases it. It rolls off the machine, and then we put it in a stack over here. These are rolls that are waiting to go to the manufacturer of our panel. Once when we get to that point, that machine's job is done. It's made the mesh, and now we come over to the actual mesh welder. The panel welder. This is the one that's down right now. So the way this machine works is one of our raw goods is expanded polystyrene. We choose to use EPS, expanded polystyrene, rather than XPS, which is extruded by choice. One of the purposes we use this for is when this is melted, or if it is has a fire that it's exposed to, it doesn't burn. It has a very high flame resistance. It will melt, but you can hold a torch on this and it looks like it's burning, but as soon as you pull the torch off, the flame's gone, and the mesh, the foam just melts and retreats. Mm-hmm. So this is 1 pound density. We can use up to 2 pound density, and we're also working with a product called Neopore, which is made by a small company called BASF. And
yeah, small company.
Yeah,
right?
a little sarcasm there.
Yeah.
They have infused expanded polystyrene with graphite, and that graphite adds a lot to the R value of this foam.
Oh wow.
So we feel like that's the future. That's where we're headed. That foam, instead of being white, is more of a gray or a charcoal color, same color as graphite. Mm-hmm. So we will have that option available.
I assume at a much higher cost.
it is higher, but it's not that much higher.
Oh, okay.
So that was one of the reasons why I was really excited about it, because
do you know about what kind of R value per inch we might expect on that?
You'll be between a 5 and a 6.
Between a 5 and a 6, and
so a 4-inch.
And currently that's
4-inch.
This XPS gets, EPS.
EPS.
This is
just under 5.
Just under 5.
Yeah.
Okay.
So we're exceeding the energy code, but just barely.
Yeah.
And we'd like to see that from our standpoint much higher. So that's why we're trying to get to that 6, which would give you an R24. So this way this machine operates is we have our foam here that we talked about a little earlier, and this is EPS and why we use it. And what we have is, as you stand here and look at the machine, we have 1 roll of mesh on the right side, we have 1 roll of mesh on the left side. Those 2 rolls are fed into the machine and they come together. And where they come together is where this foam is going to go right down through the center of the 3D welder, and then when you come around here on this side over here, and again I apologize, this machine's down today, but this mesh travels off this roll, it goes into this system here, it goes into a couple of big wheels here, rollers where it's flattened out because the mesh still has a little bit, it's rolled up. We want to take all of that coil out of it. So it goes through these. Right here, it starts into a track. You can see right there. And that system brings that mesh around here. When it gets around here, it's 1 inch off the foam on both sides. So you got mesh on that side, you got mesh on this side, and then right here is our truss wires. Our truss wires are pulled off the roll. They go through quite an elaborate set of tensioning wheels here. Once they go through those tensioning wheels, this bar over here, it has some reverse teeth on it. So as the wire comes through it, it can't back up. So it gets there, and then these rollers, these shooters right here, push that wire through. It can't back up, and then it cuts them off. So these wires pierce the foam just exactly a certain distance, and then they're cut off. So the foam acts not only as an insulation, but it holds this truss wire in perfect position for the next step, which is where it gets welded. So let's walk around there. So we get to this point, and if you look back in there, there's a set of welders on this side, there's a set of welders on this front side. The foam and the mesh pass between it, the truss wires are through it, and then the welders actually come forward and weld. And they weld again, 50 welds here all at once. So that's all welded. And then the next step is a trimmer. And if you look in there, you can see those are like big sets of teeth in there. And those actually move forward and actually sense the mesh, and then they cut and they trim all the, when those truss wires are pushed through, they're a little longer than the space. And so after they're welded, there's a little piece that's hanging out, and those are all trimmed off. Then once we get to there, then this out here is all about just stacking and things like that. We go through a lot of QA, QC. The QA, QC all takes place here, so that when we get it over here into the fabrication shop, that's all taken care of. And then over here, our fab shop manager and his group, they have the set of plans for the building, and each page is a different set. So we'll just take this one for example. This is a project in Indianapolis, Indiana. It's Project Bruin. This particular document is East Wall Panel 7. So every one of our panels are labeled. So as they leave here and they get there, everybody knows where they go, okay? So this is the panel that's going to come out of the formwork. This is the panel built with our system that goes in the formwork. And this is what they build here. Once they receive the panels from the machine, they actually build this panel right here. They stack it in a certain order, so when it gets to the job site, it's just take the top one, put some mesh along the edge, flip it over. Take the next one, put mesh along the edge, flip it over. And on our website, there's a video that shows this. And you can watch that video, and it really lays it out in a sequence where it's easy to understand, and you can see how these go together. We cut out all the doors, all the windows. Any place that, we allow 2 inches along each edge. There's an eighth of an inch between each panel that's allowed. So everything fits on the day when we're ready to pour concrete. And that whole system is put together, and then it's stacked. And then maybe they'll make 20 or 30 of them and get them all stacked up, and then it's time for the day to pour concrete. They'll bring the concrete in from the batch plant. We have a specific mix designs that needs to be used, a certain slump. All of that kind of stuff is in the drawings and the specifications. But they bring that concrete in, and they'll put 3 inches in the bottom of the form. Then they'll pick up our system with a grade awl or an extension lift, and they'll just swing it around and set it right in the formwork. And then if they're trying to hustle and hurry, they'll maybe buzz it with a plate compactor just real quick, so we make sure it's down.
How about we look at a panel, and then also do you have with the concrete, with the panel
We're
exposed?
loading one out there right now that's a 6x8 that has the concrete on it. And I'm sending it to Atlanta to one of our sales groups out there. And we build it.
Can we go ahead and take a look at that?
Yeah, we build it as a tilt up.
Okay, because I think that would really help to illustrate why this is such a great system.
Sure. Tap on that.
This is all foam. Is this the 2 pound?
No, that's only 1 pound density, but that's our recycled. That comes out of that.
Oh.
This is our recycle stuff. Can you believe how solid that is? So we put this together and we hauled it over to the Tilt Up Concrete Association Expo in Denver, Colorado last week. And as you can see, this has our panel inside. It has concrete all the way around the edges. It has, this is the 2 1/4 wide, the 3-inch wide is on the bottom. It has a pick point, a bracing point, an embed plate for panel-to-panel connections, and then it actually has a pick point here that's actually in use because that's how we picked it up over there.
And so this is to illustrate how the tilt-up system works.
Yes.
So,
but actually, this is the way the stand and shoot works too. It's just that when you do stand and shoot, you stand up the panel, build the structure, and then you come back and put the shotcrete on it with a shotcrete gun.
mm-hmm.
This is being made in formwork, where you put the concrete down, you set our system in it, it sinks down until the foam rests right on the concrete. Every time it does that because it just sinks. When it gets down to the concrete, it can't go any further down because as foam it floats. So, and then we come back and we put concrete on the top, and so we've created what I call a sandwich panel on steroids.
So let's take a look at the actual structure of this. So
Okay.
The panel machine, when it takes that wire and then the foam,
Mm-hmm.
it's actually putting the foam in between 2 layers of this mesh.
Right.
And then
Those are
these
called
we have
diagonal truss wires.
the diagonal truss wires. So if we look at these diagonal truss wires, these alternate, right?
Yeah, they're set up in the shape of a pyramid. Now our panel has a strong direction, so if we're doing walls, we want to make sure that those pyramids are running like this up the wall. Okay, that way the weight of the roof system is all transferred down through the walls down to the footing. If we're doing, say, a fence or a spandrel panel, you want that weight transferred horizontally.
Mm-hmm.
Okay, so we turn the panel a different direction.
And so what we're talking about is this right here. This line is the strong direction,
Mm-hmm.
and this would be the weak direction.
Correct.
And with the alternating, the pyramid shape of these truss wires,
Right.
that basically not only does it create that lateral stability in between the 2 mesh layers, but it also holds that foam
Exactly
in between,
where it needs to be.
so it can't
Move.
So that if you shotcrete it, it's not pushing that foam down further, right?
Yeah, see, if they're on an angle like that, and the foam's in here, if it's pushing this way, unless you hit it hard enough to make it cut through the truss wires, it's going to hold it right there. And it takes a lot of pressure to make that foam cut through those truss wires. And our truss wires are on, they're on a 4-inch dimension average. So there is a lot of truss wires in that panel. And that's when I said earlier, I've had people come and they've said, well, we've seen your panel, but how do you put all those truss wires in there and individually weld them? And that's when I said I don't. That's done with our equipment. And our equipment, operates at very, the tolerances that we have to meet are high. So it's not like if I'm putting this together and I have over a 2% on a whole panel where the truss wires aren't perfectly welded, we have to go back and weld them by hand because they don't meet our specification. They don't pass QA, QC.
And so what's this right here?
So this is a pick point. This is the same thing that right there is. This one is, this is just to show you what's on the bottom below that, which is what they pick this up by. So, a lot of people say, well, you're picking up all that weight off just that little hook. And I'm like, well, there's a lot more to that hook than what meets the eye. You look at that, there's leg that goes this way, there's a leg that goes the other way, and there's a plate on the bottom.
Now, obviously, this is creating a thermal bridge at this point in the panel. So obviously, this is the tilt-up system isn't going to be a perfect.
Well, if you'll notice, there's foam
right?
on the bottom. So that shuts the thermal transfer off right there. So the foam isn't melted all the way through. When we first started this, It was melded all the way out, and you really did have a thermal transfer there. But now we've put foam back in, and we use a denser foam, and we use 1 full inch of it on the bottom. So therefore we shut off most of that thermal transfer.
Okay, but it does still essentially work like a window in terms of the energy performance. So we're going to be closer to an R5 for that little spot.
For that little spot.
So if you wanted to get really into the weeds of energy modeling, the energy modeler just needs to consider every pick point is going to be treated like a 1 foot square window with about an R5.
Yeah, something like that. Yep.
Okay.
Yep. But again, spread over, if you think about these pick points, there might be 6 or 8 of them, and we're talking about a wall that's 65 feet tall and 30 feet wide.
Mm-hmm.
Okay,
yeah.
So it's not much. One of the nice things about our system is the fact that it's been tested. The dew point is on the outside of the wall, mm-hmm. and that matters to architects and engineers. Most people, like home builders or general contractors, are like, well, why do I care about that? What that really tells you is we've actually had our panel tested for R value, and one of the things that they noticed was the fact that it took 26 hours to get the heat from one side to show up on the other side of the wall. Now, that was in a testing center. Out in the real world, the sun's shining on one side of the wall and the heat's there. By the time it gets through to the other side, it's night and the heat's going back out.
And this is one of the things that I wanted to illustrate on this panel. Just one of the big biases in the energy modeling software that really annoys me, because it completely discounts the value of concrete in general as a structural material, because of the focus on R values. Concrete has a very low R value.
Almost nil.
However, everybody knows if you're in the desert Southwest, you want to be in a concrete home. Because the Pueblo people, the Anasazis,
yep.
all their structures were what?
Yeah.
They were built out of stone, out of
rock.
masonry,
yeah.
right?
They,
and the reason is because at nighttime it gets really cold in the desert, and that concrete takes that coldness and holds on to it. And then during the day, as it's warming up, you're still feeling the cold from the stone
mm-hmm.
or the concrete. And so in this case, we've actually got a thermal barrier in between the two layers of concrete. So on the inside, where we're conditioning the space, we have an air conditioner that's actually setting a thermal point. That's getting embedded into the thermal mass storage of the concrete on the inside of the panel, and then putting that energy back.
Mm-hmm. We kind of like to call it a thermal battery. The temperature that's on the inside wants to stay that temperature, whether
mm-hmm.
it's hot or cold. In the winter, you can heat a house that's made out of our system with a much smaller heating and ventilating system, because the temperature just does not transmit through it. Even though it's like you said, concrete's R value is almost nothing, but put it next to foam that has a much higher R value, and then look at the actual transfer rate, or U value. The U.S. is about the only country that actually still uses R value, because R value is only the value of one element, the concrete. The R value of the foam is just of the foam, but it doesn't tell you how they act together. To do that, you have to use U value, which is the transfer rate. And the transfer rate on our system is extremely low. It's like 0.027, something like that, which is, very, very slow. R value, you want it as high as you can get it. U value, you want it as low as you can get it. And so, that thermal battery, is, like we like to call it, the heat is actually in the wall. We're not heating air. We're heating that wall up on the inside, and then that wall holds that heat, and it'll hold it all night and until you have to heat it up again. But our testing is showing that to get heat from one side all the way through to this surface here takes 26 hours. And I'm like, yeah, the R value is not that great, but the U value is right there. I mean, it's awesome.
Now, this is a great panel to be able to show how it all goes together, and so definitely thank you for illustrating this. So one of the other things I noticed as I was walking around earlier was some of the samples of the walls that you guys have done.
The tilt-up walls?
Yeah, some of the tilt-up walls with different finishes. Can we take a look at that and talk about the process?
Sure. I mean, this over here is, are you talking about the fence?
Yeah, the fence walls.
The fence walls? Sure. I when the company was back in South Carolina, I spent a lot of my time working with finishes. It's just something I like to tinker with. And so when we got out here, I wanted to put up, just some walls so that people could get a feel for, everybody says, oh, you live in a concrete house? I'll bet that's an ugly house. Or, they just don't picture concrete as being something that you can get some interesting finishes and some different looks. So we built some walls here, more just, for things to look at rather than trying to keep the whole world out. And I had actually built this wall on a house in South Carolina. We did the base color almost a white, like the columns, like that column there is. And then we used this rock work, and we put some decorative iron work in this circle.
And in this situation, this is actually veneer stone, or
this is veneer stone. Everything else is actually cement.
So the stucco is actually cementitious.
Yep.
Troweled on.
This is what I call lick and stick rock.
Okay, and then this is lick and stick rock.
Yeah.
And it looks like we've got kind of a wood texture over here.
Yep. Pardon the weeds,
And so this is one of the things I love about concrete, the fact that you can it takes the materiality of whatever is pressed up against it, even though this looks like it was actually done more of an artistic rendition and not actually a pressed board into it, right?
Yeah. So what I was trying to do here is this section down here that's brown is actually concrete. This is acrylic.
Okay.
This comes out of a bucket. A lot of people,
So the acrylic, this is like the stuff that they have on EFIS, exterior insulating finishing systems,
yep,
right?
Yep. So what we did was we had it colored a light gray. We spread it out on the wall. Then we came back and we took a textured roller and put the texture in it. Once we put the texture in it, then we just came back and we cut our board look into that wall. And then I have some rubber knots that I just pressed into that material, and then we let it dry.
And this is something that kind of depends on the skill of the installer, though.
Actually, the reason we did this is called do-it-yourself. Anybody that can take a trowel and spread material can do this.
I'm pretty sure I would screw it up.
Nope, I can promise you wouldn't.
I screw up drywall.
Well, I do too. I hate drywall.
Oh, drywall's horrible. It's such a simple concept of how to do drywall, and yet I screw it up every time.
Yeah.
It always looks horrible when I do it.
So that one down there, like I said, that's an acrylic. This one is actually a Type S mortar that we mixed up in a cement mixer and spread it out, and then we did the same thing. We put the texture on, then we cut the lines, and then we made the knots. And then we came back 3 or 4 days later and we used some different colors and highlighted, because the base color of that is a very, very light brown. And then we came back and sprayed a darker brown. Then we used almost a reddish and a charcoal to make the knots stand out. And then, then you seal it, and, you can put red dirt. And this one right here, this product here, the sealer that we put on it, they give us a guarantee that you could spray paint, you could tag this, and you can wash it off with a garden hose.
Oh, nice.
So, you know, the days of all that kind of tagging
That'd be
are
really
gone.
good for potential customers in Portland, Oregon.
You better be careful how you say that. Here's a couple of more. This is just a plain, more or less
Plain
a stucco finish.
So tell me about this brick one.
This brick it's done the same way. We just put the material on thicker, and we just put the material all the way along. Now this particular one, we had a guy who wanted a rough looking brick. He didn't want this. He didn't like this.
Yeah, so this is more of your
new brick.
This is your typical machine cut brick. That's right.
This is like old brick, cut face. You know, that was the look he was after.
Now the thing that you'll notice, and I'm saying this to my viewers, so like the thing that you'll notice right here is the colors right here on the face, and you can tell the sides of the brick are actually concrete.
Same
it's
color.
actually the mortar. So it's actually this is a stamped brick. It's not actually real brick.
It's not even a stamp.
It's just cut.
So we took the material and we troweled it on this thick. Okay, then it's so difficult. It might take a PhD to be able to do this, but you trowel this on. You just simply come back and hold a level. Have two guys hold a level on one end. So we started down here, and we held the level here, and I made a tool that you just cut it. And you're just cutting this material, and it just falls out. And then you come back once you've cut it, and you cut the bottom side of the level for the first ones. Then you just come back and you measure how long you want the brick with a tape measure, and you just hold it. So you hold it there, you cut this one, you cut this one, you cut that first line, and then everything else works off that line just by half.
So it's definitely a lot more labor intensive.
Not really. It's really easy. The hardest part is mixing up all that mud.
Okay.
And that's why we wanted to try something that was an acrylic, because that comes out of a bucket. A 5-gallon bucket, and you can spread it on. But you can't put that acrylic on this thick. It doesn't work. We tried that.
Yeah. Okay. No, this is amazing. Now, I think do you also have like you can also stamp stones and bricks?
I've got some
too.
in
Yeah,
the
you've got some
shop.
inside the shop.
Yep. So this is a stamp.
Okay.
This is a stamp. This is the same stamp. I just use different colors. Okay. This over here is a stamp. This over here needs to be wiped down, but I've got 3 houses in Park City right now.
This is also stamped.
This is the exterior of their house. They're above the ski runs.
This is actually the finish that I want to do on the inset part of my office.
Yeah, I have these stamps.
Oh, that'd be great if we could use that, because my plan is to have like a white stucco look for that overarching part, the roof and the west wall, and then the inset part on the south, east, and north. I'm planning on doing a wood grain finish, so it kind of makes it look a little bit.
This is really dirty. You clean that up, it looks amazing. I have so many people that look at that and they say, "I can't believe that's a stamp." And I'm like, "Well, there's our panel.
There's the proof.
There's the panel. Here's the concrete. There's the addition right there. That's all the thickness you got."
That's so cool.
Here we go.
So hopefully you've enjoyed that tour of Tip's factory where I'm giving my panels, and the next video in this series will be actually erecting those panels on site, and we'll start seeing what the building's supposed to look like. Well, hopefully. Anyways, Glad you enjoyed it. I'm the Colorblind Architect. Peace out.